All right, on time. Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining Going Meta Season 2, Episode 6. A little special episode today with more of a Q&A and a feedback round. But first of all, hi, Jesus. How are you doing? Welcome to the show.
Hi, Alex. I'm very well. Great to be here, and it looks like you're in an unusual location. I think I'm familiar with that place. I think I've been there before.
Yeah, probably. Yeah, the typical. Yeah, it's JFocus this week in Stockholm. Cold Stockholm. So I'm here since the weekend and spent a bit of time walking around the beautiful city of Stockholm. But it turned very cold on Sunday and -5 or something, and it snowed this morning. So
Wow.
it's nice looking outside, but it is also very cold. So good, I have my big winter coat with me, so I don't
Excellent.
freeze too much.
Good. I hope it was a good conference, and you had a chance to talk to many developers there.
Yeah, it was a good day today. It's continuing tomorrow. Yeah, we had good conversations, good people there, good crowd as always. So I think JFocus is a good event to go. If you're ever in the Nordics, or if this is your home, then I guess you know JFocus. But if you're not, then check it out. It's a nice event.
Excellent. Yeah. So I thought it would be a good idea. I mean, we've spent the last close to 5 or 6. It is episode 6. So I think the first 5 focusing very much on knowledge graph construction, a little bit of RAG, and I thought it would make sense. First of all, I wanted to. I had the impression that the last episode was a bit too dense, and we rushed a little bit to the end. So I wanted to do a mini recap and then complete it. And then I thought, well, rather than starting an entirely new topic, maybe take the time to go over some of the questions that we've been seeing over the weeks and through different channels, and maybe address them, and also make a little bit of an Ask Me Anything. So if any one of the people who's joining live have questions, by all means, drop them on the chat, and we'll be more than happy to take them.
Yeah, exactly. So everybody is watching. I mean, I can only, and if you watch this regularly, you know this, I can directly reply easily here from the system we have into Twitch and YouTube. But if you are watching this on LinkedIn, don't worry, we see your questions. We can obviously answer to your questions. I have a bit more difficulty in sending messages to LinkedIn because of system, restrictions, but don't worry about it. I see you, and we can definitely cover those. So yeah, it's a good idea. I think we had a couple of questions. I think we collected already over the past. So people asked some things. So we're going to look at that, and yeah, with new questions, there should be time today for a couple of those. And as always, I mean, if you watch this and you couldn't watch it live and you have a question, put it in the video. YouTube, best place to put questions in is YouTube comment section, and then we have a look out for your question, and we can look to answer them either in writing, or maybe we cover some of your suggestions, your questions in the future episode with a bit more detail. But yeah.
Perfect. Okay, so as always, let's cover the first part and do this kind of recap of last episode. Let me know when you can see my screen.
Yeah, I can see your screen.
Yeah, well, didn't spend much time thinking about the title this week for a change, so we just left it at questions, questions and feedback. But yeah, I wanted, and maybe let's go into full screen for this slide to make it more readable. But you probably remember last episode, after looking at building a knowledge graph out of mostly unstructured data, we looked at the knowledge graph builder for a no-code approach to it. Then we looked at the GraphRag package for a fully code-based approach. And then in this last episode, we wanted to combine structured and unstructured data and what we call like mixed data of feeding into a graph. And I was particularly interested in showing how at the center there's a common driver for both pipelines, and that was this idea of the ontology, or the target schema. We could call it in many different ways, but it sounds like ontology is a commonly understood one these days. And while an ontology can take different shapes, in our case, we started with the standard W3C serialization. I believe we used, as always, protege or web protege to create it. And basically the ontology describes our domain. And the example that we worked on was kind of a sales data set where we had data coming from a CRM with customers, with purchases, with locations, the standard information that you will get in a kind of a sales data set. But then and that was structured, of course, that was in the form of tables. But then we had also two additional sources of unstructured data in the form of PDFs. And those were there were credit notes, like for refunds, for returns, right? And these were like PDFs that contain a description of the reasons why a product had been returned and in reference to what order. So there was a way of linking it to the original data set. And we also had like product descriptions. This was, again, generated data. So, but it was, you can think of these as a product spec with more details on the products that were actually mentioned in the CRM data, where you had like each order, each purchase had a reference to a product, but then the actual product description came from an unstructured document. And the idea is that with a single ontology that described the whole domain, a single model, we could feed both the data ingestion for unstructured data, and we did that through the data import tool in our Aura console. But we also used that ontology to provide the context to the knowledge graph builder pipeline for unstructured data in the GraphRag package. Because you probably remember, and Alex, I'm sure you remember that we did that first time, I think, in the knowledge graph builder tool. We looked at creating a graph without giving any guidance, and you get a graph, but it's not very usable. So it was kind of I would call it a strong requirement to give these kind of guardrails in the form of these are the types of entities, these are the types of relationships. That's the terminology that I want to use. These are the labels, the property names, the relationship names. Because if we want the two data sets, the two pipelines to build ultimately a cohesive and unified graph, that was required. So we saw how these ontology could be. I mean, you could start at any point. We started with the OWS realization, and we created a data importer model, and then we used that also to create the GraphRag config. But that can start at any point, and I think we showed briefly how if you start from a data importer model, you can also serialize it as RDF. But let's take a pause there. So that's as far as we got. I mean, there's a couple of little things, but we agree on that, right? So that's
yeah. I think this is particularly important. Also, differentiation between RAG and GraphRag that comes into play here. I think because people might be confused. Okay, but what's the difference here? I think this is explaining it also very well. Say, okay, you have vector search, and you can throw your vector in the grid, and then you find other vectors that are similar, and you find those, and you find through similarity results that come back and that give you the similar answers, and you can go to a relatively okay, I would say, answer sometimes, but it's a little bit of luck every time involved, that you find the right question that gives you the right vector, that finds the right similarity with other chunks, and then gives you the response back. But here, this is just you can start with the vector somewhere, but then you follow the graph. You give you guidelines. It's what you said, guardrails or scaffolding. You have something around there that helps your query to become more contextualized, more relevant, and more true in the end. And that is what the beauty of this is. If you want to do something with the GraphRag part, I think this is why it is so important to include this ontology, data domain modeling, whatever you call it in the end. But it is really it has to be, I think, an integral part of what you do. Otherwise, you're fishing in the dark a little bit, and you're relying on too much randomness, I think, in the end.
Yeah, and we're going to look at exactly at that part, because yes, you're right. I mean, the graph that we built combines the two parts. I mean, you have a vectorized data, and we saw how the GraphRag package, as it reads the content of the PDF, it builds this double-layered graph, right? So the one that's built by chunking the document, in this case, just in a sequence of paragraphs of portions that get vectorized and added to the vector index. But then at the same time, we do these entity extractions, and we detect that this document that we have vectorized first also contains a mention of a product. So we're going to create a node representing that product, and it contains a mention of a customer or of an order, and we can link those things together in what we call the domain graph. And there's a reference to the underlying we call it lexical graph, but it's the graph that's vectorized, and that's not the only source of unstructured data and vector data. We see that also very often when we're loading only structured data, but that structured data, let's say in a data warehouse or operational database, contains some long form text. So it's very often, I mean, here we're playing with a toy kind of CRM, but if you use something more advanced like Salesforce, you know that Salesforce has long text fields where you can enter a significant amount of text that we might want to analyze, vectorize, and do semantic search on. And ultimately, what's important is whether that comes from this long form text or from separate sources that ultimately converge into a combined graph. The powerful thing with Neo4j is that we offer the two ways of representing or capturing knowledge in a way. One is the vector-based, the kind of, this is more opaque, that's driven by the models that create the embeddings. It's not so explainable. It's like you were saying, I mean, I do a search and there's some similarity, and it can return the closest vectors. But what's really powerful is when you can combine these vector representation with explicit entities that are connected to these vectors. So what you can do is not only do a semantic search in the vector space, but also contextualize it by navigating the relationships, doing aggregations, sometimes we will even ignore the vector index and start with trying to generate a structured query directly. So what we're going to see is that by having this rich representation of data that combines vector and graph, what we offer is multiple retrieval patterns. And sometimes it's going to be text to Cypher. Sometimes it's going to be vector plus contextualization. Sometimes only vector. But it's the richest sort of offering in terms of retrieval options for RAG architectures. That's what we mean by graph RAG, and that's what exactly I wanted to sort of finish last week's experiment and show this graph part. Although, like I say, and you remember, Alex, we've touched on these in other episodes, and I'll make reference to some of these in a minute. So does that make sense? So
no, that sounds good. That's great. Yeah, perfect. That's very good. Yeah,
perfect. So let me go here, and now I'm going to jump. Before I jump to the code, let's maybe refresh people to show where we ended. So this was our Aura console, and you probably remember how this model was effectively the ontology, the portion of the ontology that we used to load the unstructured data. So we had customer information, location information, and purchases information, and we mapped those files to the properties and the entities in our ontology. So, for example, we said, hey, there's a notion of a customer that's let's make it a bit bigger. A customer that has an address, a purchase that's done by a customer and of a product. So there's connections there, and these are all populated from these files. So what we did is, for example, for a customer, we indicate, excuse me, which file populates that and what's the correspondence, the mapping between the columns in the source file and the attributes in the graph. And once we've defined that, and that's what we did, this is just a question of running the input with one button, and that would populate our Aura instance. And we had we did that, and then in parallel with the code, we did the unstructured data extraction, and we ended up with the graph that I'm showing here. So we can take, for example, some purchases, and I can actually expand one of them and maybe zoom in. And well, this is a purchase, one of the objects in our ontology. You can see how that matches. A purchase is connected to a product and to a customer. That's exactly what we're seeing here. We can change a little bit the presentation and say for a purchase, we might, in this case, it's showing the quantity, but we could, I don't know, use the purchase date or the ID, whatever is useful in this case. This is the product. We only have, remember that in the CRM information, we didn't have much product information, just the product ID, and that's why we only have a property here, in addition to the internal identifier. And then for the customer, we have the customer name, the email, and an ID. So that's the kind of graph that we created, but there's some additional elements. I don't know if this one will exactly. So a customer will do several purchases, will have in this case an address, and so on and so forth. So that's the graph that we have. That's the structured data graph. But then we also have from the unstructured side, and we'll see that we have chunks. These chunks, they will have portions of text. This, for example, is the description of a product. Remember that we had two types of unstructured sources: product descriptions, documents representing product descriptions, and credit notes. So if I expand this product description, we see that it comes from a document, and we have the reference to the document, which is one of the data product descriptions. And we have extracted an entity from this description. And this entity is, not surprising, a product. Now we have a much richer description of the product. We still have a product description, a product ID, and I'm going to touch on that because I've run it separately, and I want to show how I solved the problem, because there's two options when you combine data from different sources, right? If you have a unique identifier that works across both sources, probably things will link nicely, and that's exactly what happened. Maybe we should look at credit notes. So if we look at the credit notes, which was very similar, right? So as a credit note, maybe I should use a different element to refund reason. Well, anyway, that's not super important. But the important thing is a credit note comes from a chunk. So that's something that we've read from these unstructured source. So we still have the text in this file. We have the vectorized representation of it, but we have extracted an entity, which is this credit note. There will be probably additional elements on there. So there's not only the mention of this credit note, but there's also an address, and there's a person, a customer, and there's an order reference. So I can show briefly the kind of information that we found in the credit notes, but it was something like this. So we have a credit note ID with the date, and it has the name of the customer, it has an address, and it has a reference to the purchase ID, to the order ID. So this is a refund of $300 for this order, and there's a reason for the refund. So it didn't match the description, whatever. So, but there's a way to match, and that's pretty common, right? In a refund, you make a reference to the originating order. So in this case, that worked very well, and that's what I meant. So in this case, you have a credit note that's extracted from that entity, and this credit note is linking to both a customer and a product, and it's pretty unambiguous, and this linkage works pretty well. Now, it's not always the case, and that's what I was saying. So in the case of products, and that's what I started here, we have a reference to the product, and let me go to the source data as well. If we look at the product, a product description, we'll have a product name and product ID, let's call it. This is catalog, maybe a catalog number, right? So it's product ID CAT_054. Now, that code doesn't match directly to the information that we had from the structured data, because if we look at the purchases here, look at the product ID. Let me find it. Here we go. So product ID is just the numeric part. So all the prefix is not there. And while there is kind of an obvious match, we're going to have to add some, in this case, minor logic. It can get more complicated, but I wanted to illustrate that with this example. So here there's a small string transformation. So the information coming from the product description contains a small prefix that's not present in the structured data. So we need to rectify that. And the way we did it, and that's already run here in this data set, is by running a simple fragment of Cypher. Let me share that with you. I'll put it here and I'll comment because it's pretty straightforward, but still worth looking at together. Let's make it full screen. That's not very big, but maybe we can make it a bit more readable. Hope that's perfect. Better. So
actually just came in chat if the linking with the product automatically happens, or if we have to do something.
So yeah, basically what I was doing here, and I'm using some of the recent syntax that was added to Cypher. So I'm trying to match products. So there will be products, I mean, things labeled as products in my database that come from the input from the CRM, and there will be products that come from entity extraction from the credit nodes. So interestingly, all the information that comes from entity extraction through the knowledge graph package gets an extra label that's this entity. So that for me is a useful filter, because I can say, okay, I'm looking for the things that are product, but also labeled as entities. And we'll see in a minute what these look like. So this would be, in this case, hang on, I've made it so big that now it's a bit, hang on, let's not get this one. This would be, oops, where was I? Hang on. Let me make it a bit smaller, because otherwise
maybe, yeah, exactly.
So got lost here. Let me remove that part. But hang on, these are the credit notes, which we don't need. These are the chunks. This is a purchase. Well, maybe we can just look at products here. So we click on products, and we'll see that actually the coloring tells us, right? So you see that some products that just contain the ID, these are the ones that come from the CRM. Remember that we only had the product ID, but the ones that come from the entity extraction, they get annotated with entity, but they have a lot richer information, right? And they have the product spec, the ID, the product details, all the text that was coming from these files, right? The details, the key features, etc., etc. So all the information that comes from the unstructured data. Right, so these, my way of identifying these is, okay, this is something that has been extracted from unstructured sources, and therefore it's annotated as product, but also as entity. And actually, it's an entity with underscore. So my was my query not all right? Well, maybe, I don't know if I wrote it right. But anyway, I want to identify those. So it's probably that should have been the correct. There you go. So anyway, that's it. So I'm trying to find things that are product and entities, and things that are product and not entities, right? So the ones that come from the CRM will be also products, but will not be entities, and that's what this notation indicates. And I'm going to do the match, and that's my hacky way of doing. Remember the difference. One of them had this format. You see it here. So it was CAT underscore and then the numeric representation with some zeros as a prefix. And the ones from the CRM just contain the numeric part. So what I do is I take, hang on a second, did I do this right? So I think it's the P1, which are the ones that are coming from the unstructured data. I do a substring removing the first 4 characters. So basically I'm removing the CAT and the underscore and just keeping the numeric part. Then I convert it to string so that I remove the zeros, and then to integer, and then I reconvert it to string. And like this, I get a match. So that's my way of filtering. Does that make sense? So I'm basically stripping out all the prefix and the zeros, and just keep the 459. And when the 459 matches the number on the other side, and that's what I'm doing here, where the product code for the product 2 equals this transformation on product 1, then I've found a pair of matching products. And the way I do it, I mean, I could have done it manually, but there's a very convenient function in APOC, which is called merge nodes, that given 2 nodes as parameter, or n nodes, actually, I can pass a list, but in this case, it's only 2. It will just merge them and literally create a single node. You can pass additional configuration here and indicate, hey, I want you to do it in an override mode. You can see all these sort of things that you can pass. So it's the list of nodes, but there's a lot of configuration that you can pass, and you can indicate how do you want the collapse to take place, how to deal with the relationships. There's so many additional things that you can control. But in this case, I just wanted to take the default behavior, and it's merged the nodes, and now I have perfectly connected. I've run that before, like I was saying. So if I run it, it's not going to produce anything else. But now it's already linked. So basically, I had to overcome this kind of problem, this kind of limitation that is natural when you combine data from the different sources, which is kind of the entity resolution. But now what I have, and we can probably show it in a simple path. let's say that we're going to have now, for example, we're going to have credit notes, a credit note that's connected to a credit notes were connected to purchases, and purchases were connected. I'm not specifying the relationship, but I could do it. Are connected to products, and some products will come from will be connected to chunks, right? Because they come from. So these show how everything has been connected together, hopefully. So let's see if I return P and limit it to 3 paths. There you go. So now we have complete paths that start in structured data and go all the way to unstructured. So if I start here, for example, this is a product information that has been retrieved from this chunk, and if I expand, it will be connected to the document, right? So this is the document with the product description for product catalog 54. This is the product in question, so it's a smartwatch, and we have all the description. And this has been hang on, if we expand it, that's not what I was expecting from chunk. So this is the product, sorry, and this has been purchased. So this is a purchase. Exactly. So this has been purchased, this product, and this is connected to in this case, to a credit note. So we can navigate now from between structured and unstructured, and we have the complete graph. But yeah, that's the bit that I've taken a bit longer than I was expecting, because where I wanted to go is once we have the connected graph, what we can do is now start doing the RAG part, which is let's interact with the graph. Let's ask questions using LLMs and have the retrieval step using all the different patterns that are available in Neo4j in the graph. And for that, again, I'm using
maybe quickly before we do that, because there was one question from Lila, and I think that's a good one. Is how did, maybe if you missed the previous episodes, I think it is maybe a little bit unclear, but you know, how did the chunks get automatically annotated as product was part of this modeling ontology exercise we did last time.
That is correct. So the let me show, this is documentation. So we're looking at the RAG today, but there's the knowledge graph builder. So one of the things, and that's what we did last time, the knowledge graph builder. So one of the things that you can do is pass information about the schema. So we use the simple, where is it? I believe there's a user guide, entity resolver, knowledge graph. Right? I think there was knowledge graph builder components. Yeah, the simple pipeline, because we went with the simplest approach. So basically, and this is the code already in GitHub, so you can have a look at that. But one of the things that we can do is customize the behavior of the pipeline, and precisely by passing the schema, right, which is the ontology. So there's a particular format that the knowledge graph, the graph RAG package uses, which is basically a listing of the entities, the description of the items, the properties, the relationships, etc., etc., and all that is in our ontology. So we had a method that would take the ontology and generate that dynamically. So I can quickly show that to you, because that was this simple pipeline. And instead of creating the schema or hard coding it like we were seeing in the code, we were using this function that goes and gets the schema from the ontology. The ontology that we were using is the sales ontology. And the sales ontology is here, and we have a definition here of all the classes. So there's and the notion of a store, a purchase, product, location, customer, credit note. There's the relationships, a refund reason, a refund. No, these are the properties, sorry, and the relationships will probably be at the top. Refund for. So all the information is there in our ontology. This method that was in the simple pipeline takes the ontology. And that's what this method does, iterates over the items and generates, it's just a bunch of lines. It's not super complex. And it would return the ontology, but basically presented in a way that the graph RAG package understands and uses to create the graph exactly in the form that we expect. And that's what you were saying, Alex. We want to be very explicit about not only the shape of the graph, but the terminology. I want the entity extraction element to create things that are labeled as products, because like these, they're going to match directly with the ones that are coming from the other sources. And when there is a match, there's this, and we saw that in the previous episode, you can specify the properties that are unique identifiers. So if there is a match on a property that's unique identifier, then a merge will happen naturally. Now, it didn't happen in this case because there was not a match. There was a slight difference in the naming. One was using this prefix and the other one wasn't. So we ended up with two separate nodes, and we had to add this additional step of matching and merging. Does that make sense?
Yeah, that makes sense. I think that's good.
So that's where the magic happens. Yeah. So if it doesn't come from an ontology, it's not a problem. You can hard code it like you see it here, and you will need to pass the entities with their attributes, the relationships with their attributes, and the potential schema, which is the triples subject, predicate, object, right? And that's it. You pass that to the knowledge graph builder, like we did in our code, and that will drive the extraction. So in our case, we just take the schema from the ontology. Now, so we have built the graph, and now we're going to go into the RAG part. So we're going to interact with the graph, and that's what this section in the manual shows. And there's a number of retrievers, because ultimately the key thing here is the retrieval part. So we're going to in a RAG workflow, what you do is you ask a question to the LLM. The LLM will go to the external source, in this case to the graph database. And retrieve the information that it needs to accomplish the task, to answer the question that you're given. So the question is that you have to offer the retrievers that can provide the information that's needed. And I've literally again gone with the most basic approach. Most of the times copy pasted this code, and we have a number of retrievers. So the first one, just to start from simple and going up, we start with the vector retriever. So we have vectorized information already in Neo. And you remember what that is. This is the information coming from the credit notes and from the product descriptions. So this is in the RAG vector. So again, this is just the credentials to connect to my instance. So this is my Aura currently running instance. So that's the URI, the user, and the password. And I need to pass the vector index that I'm going to use. I call the vector index chunk index. So that's totally up to you, but in our case, we can see, we can do show indexes, and it will give us all the indexes. Some of them I created explicitly. You probably remember, just need to watch the recording. But there's, here we go. There's the chunk index vector, which is of type vector. Some of those have been created automatically by the graph rack package, like this one, but in this particular case, this one I did, and that's the one that we're going to be using. So that's the name of the vector index. So if we go back to the code, all we do is, well, we instantiate a driver to connect to the instance, and then we instantiate also the LLM that we're going to use to create the embeddings. Remember that what we're going to do in this particular case is we're going to take the question, we're going to vectorize it, and we're going to do a search in our vector index to find similarities, what you were saying before, Alex. So we're going to try to find the n closest or the n most similar matches, and we're going to use that to produce an answer. That's exactly what we do. And for that, I'm going to use...
we just wanted to say that we are using OpenAI here, but you can use other LLMs as you like it. This is not, this is just out of demo purposes. We have to use something, and OpenAI is probably still the most popular one. So it makes sense to go with that. But if you have preferences with others, the model that can be changed, and you can use other. Perfect. Yeah, easy to do.
It's already supported, so it's there in the documentation. There's even examples on how to use Azure, how to use, in some cases we see a super popular Olama, because you can run them locally, and that it doesn't incur in any cost. So yeah, total support for your choice of entirely your decision. What's the model that you want to use? So in this case, we're using this model, which is one of the OpenAI for creating embeddings. And we instantiate a retriever. The most basic one is the vector retriever. All it does is, again, scan the vector index, find a match, and then return the n top matches, right? So we indicate which is the vector index that we're going to use, which is the chunk index that I created, how to connect to the database, which is the driver that I just created, and which embedder service are we going to use. So how am I going to take the question, transform it in a vector that I can use to do a lookup in our vector index. So that's how I configure it. That's all. And then ultimately, I'm going to use an LLM to do the kind of the generation part. So in the RAG, there's the retrieval part that we just described, but there's the generation part. It's going to, since I'm going to ask a question in English, I expect the LLM to return a question in English, returning the an answer based on the context that has been retrieved. So that's my instantiation of the LLM. And here I create the pipeline. So graph RAG is the object that I'm going to use to instantiate. And I pass the retriever part, the retriever component, which is the one that takes care of the vector. And that we will change because later we're going to look at other retrievers. But then I pass also the LLM. So pretty straightforward, just the LLM and the retriever. And then I go and ask a question. So once I have this RAG object, I say, well, what do you know about smartwatches? And you can imagine the kind of questions that you can ask from. Remember that in the vector index, what we have is the product descriptions and the credit nodes. So it doesn't have much more information if we restrict ourselves to the vector index to any additional information coming from the structured sources. So I'm asking something generic, like, what do you know about smartwatches? And I call the method search, and I'm passing the query. And I'm specifying how many results I want to return. In this case, maybe the top 5, but you can say, well, give me the top 3 or top 2, whatever. And then I'm going to print the answer. That's all. So I'm going to run that. And what's going to happen is this question is being vectorized. I'm going to scan the vector index. It's going to return the top 3 matches. It's going to send that to the LLM, and the LLM is going to produce a natural language answer for this. So I hope that's readable. I can try to make it a bit bigger, but you see how that's it's produced. That we could have put it in an app, would look nicer. But basically, it combines information that's it says, well, smartwatches such as the smartwatch C8054 and 546, which are actually genuine product codes. You can look at them. 54 is one of the ones up here. So and if we look at that, oops. There you go. So that's a smartwatch, effectively, and 546 here. It's another smartwatch. So yeah, that's done the job, right? So it's done. This has been vectorized, and the results are accurate. And it's then combining the rest of the information that comes from it, some of the features, some of the what's in the box, some of the specs. So that's right. So that's the kind of simple questions that we can run from for this type of retriever. But like you were saying, Alex, so here, if the information is coming from, let's say, this is relatively straightforward, but let's say we need a bunch of elements to combine in order to provide a complete answer. And we went through that type of limitations in previous episodes, right? And how, these sometimes fall short. What will return might be part of the answer. It won't be incorrect. It will be the closest in terms of similarity, probably not the most relevant, and probably not the complete answer. And that's what we want to improve by adding additional ways of retrieving. So let's go to the second one. The second one combines vector and context, so vector and graph navigation. And again, this is not new. This is something that we saw in previous episodes. It's identical, all the code. Let me make it a bit smaller because otherwise it's hard to navigate. It's exactly the same. The only bit that changes is this central part, the retriever. I'm going to try to make it all fit on the screen. But instead of having a vector retriever now, what we have is a vector Cypher retriever. So it's exactly the same. It has an index that's going to be scanned, but it adds this additional element, the retrieval query. So the retrieval query is, okay, the vector index is going to return some matches that are aligned with nodes. What do I do with these nodes? Before I was saying, hey, produce an answer based on that. Now what I'm saying is, okay, take these nodes and now navigate out of them to get additional information. And in this case, for example, what I'm doing, and it's a pretty simple example, it's a bit of a tricky query, but what I'm doing is it's going to be product information. So what I'm going to do is try to find out of the chunks the product and the number of purchases, how often they've been purchased. So I do a simple count, a sum of the quantities in these orders. to find how often this product has been purchased. And then I do a sum on the number of returns. Whenever there's a credit note, there's been a refund. So I basically figure out for each product the number of items returned and the number of items sold. Right? So this is just 2 additional metrics. That gives me additional information, but it had limitations as well. That's great because it combines vector, which is more robust than the probably pure Cypher generation, which can be brittle sometimes. But the problem with this approach is that I had to hard code the query. So I'm only going to have and that's not a bad problem. I mean, that's not a bad thing. So we're going to see that maybe offering a list of these tools, as we're going to call them when we look at agentic RAG, is the way to go. Basically tell this is the way to achieve a number of tasks on my data set, and then let the LLM decide how to use them. But we'll get there in the next episode. For now, what I'm saying is I pass this query to my retriever, and the retriever will do exactly the same, vector index, but then will navigate out to complete the answer. And now I can ask something similar, but a bit richer, like tell me about the portable chargers and the customer satisfaction around them. So if I, the approach is pretty much the same. Hang on a second. Yep, there we go. So if I run that, maybe I should have given it a bit of a break to separate that. There we go. So the portable charger has a sales count of 130 with only 4 returns, indicating the high level of customer satisfaction, blah, blah, blah. So as you can see, it takes us an additional level in terms of using the information, not just the pure vector, but now navigating to the structured data, because this is data coming from the CRM, right? How many sales, the count of the sales, the count of the returns. So that's the second type of retrieval. And again, I won't spend too much time today because we touched on these in previous episodes. Feel free to go and have a look. But I wanted just to give a complete overview to kind of close this example. And then the third approach after the vector and vector plus graph would be the Cypher approach. So we're going to try to generate a structured query for the question that we have. Again, the skeleton of the code is identical. The only thing that changes is we create a text to Cypher retriever. And the text to Cypher retriever, instead of needing a vector index, it's not going to use a vector index or any kind of embedding. In this case, it's going to try to generate a structured query. And in order to do that, guess what it's going to need? Well, it's going to need the schema. It's going to need the ontology. I mean, you have to tell me, how do you call products? How do you call purchases? How do you call things? What's the name of the attributes? What's the name of the relationship? So that I can produce something that's syntactically correct. So that's the element that was missing here. So this retriever needs the Neo4j schema. And again, guess where it comes from? Well, yes, it comes from the ontology. And we had a method that we used in previous episodes that, again, takes the ontology, and instead of putting it in the JSON format that the GraphRag package needed to build the graph, this is going to do a pure natural language representation of the ontology. And actually, I can print it so that you can see the kind of description that it produces, because we're going to pass that in the context to the LLM so that it generates the right cipher. So let me run that. So this is going to take your question. It's going to get the schema and then pass the whole thing to an LLM and say, given this question and this schema, generate a Cypher query that's going to answer the question. And then we'll run the query and get the results. So now the query that we want to answer is how many orders have been returned for products with AI functionality in their features. So let's see how it behaves. And then, because sometimes there's errors, I mean, sometimes the syntax is not correct, or, well, there might be retries. So I've done a poor man's version of it and say, well, give it a few tries until it comes back. But just to avoid you having to see, well, that was quick. Let's see if that's a good or a bad thing. Well, that's the ontology. So that's the quick print that I did. So this is kind of the representation of the, that was too quick. Here we go. So I hope it's readable. Let me make it a bit bigger. Oh my gosh, that's not very nice, but I hope it's, so yeah. We have the note labels. So, and that's, oh my gosh, that's not adding spaces. This print, I mean, there's a nice print. There's line breaks that's skipping it. I mean, here it's not very readable, but you see that there's an enumeration of the credit note, customer, location, product, purchase, store. And then for each of the properties, address is an attribute that applies to entities of type location, branch name. It's missing the line breaks. That way, why it looks a bit horrible. But
yeah,
it's a textual description that we are passing to the LLM so that the LLM produces a cipher. And I hope it's readable down here. This is the cipher that it's produced. It's a pretty. I'm going to take it and run it on in the browser so you can see it. But basically, it's run it and it said, well, the number of return orders equals 5. So pretty cool. So that's been there might be some retries in there, but basically it's managed to generate this cipher query that we can now go here and show how it was. Well, we've seen that it returned actually the right answer, but this is the query, and I wanted to show that it's pretty. Let's remove the line breaks, but that's another line break here. Here we go. I'm going to make it full screen and enlarge a bit, but that's pretty much it. So basically it's saying, well, I know that a product has been returned if there's a credit note associated to it because it's a refund for it. So this is the query that's generated. So there's a product that's been part of a purchase, and then there's a credit note for it. And then it makes sure that the features of the product contains AI. Sometimes I've seen it running, and instead of looking for AI, it looks for the whole thing, like AI functionality, or I mean, it depends how it interprets. There's an element of variability there, and that can change the result. But basically, it looks if that's contained in the product features, and then it does a count, which is pretty cool, and it does work, and it has actually returned result 5. So pretty cool. I mean, of course, there's nuances to all these, and I know I did it very quickly, but I hope that kind of completes the picture of the story that we started to tell last week. And right, and I was hoping that would have taken a bit less, but let's look at. I don't know if you have any question, Alex, and if not, let's maybe start looking at some of the questions that we have on the chat, because it looks like
we have a bunch of questions in the chat, so I think I'd rather let's go into those. So maybe we start with one from Hutch that came in a little bit earlier. They asked, does the search prioritize the value of the node or the properties of the node? And maybe follow-up question, not really from Hutch, but from Lila. Is there a way to control how many entities are matched in the when it runs?
Sorry, so that's the match, and I suppose that's when we do the vector search. Can you read that again? Sorry, or is there a way that we can see it, have it on screen or something?
I can put it on the screen. Yeah,
that would be great, because like this, does the search prioritize the value of the node or the properties of nodes? I'm not sure I fully understand there, but what you do, I mean, if we're talking about the first retrieval, or the first retriever, which was the vector one, so in this case, I mean, it's a pure you specify the similarity function that you use, which can be Euclidean or cosine, which are the two that I think are implemented at the moment in the vector index. And basically, the vectors stored in the index are the properties of certain nodes. In our case, these are the chunks, right? I think in some examples we've done it. It's entirely up to you. You can vectorize the content of the text in any property, but there's no prioritization there. At least not when you do the vector search. What you can do is post filtering in the way that we did before, which is like, you can add, in my case, I added ways to kind of navigate the graph and complete the context, but you can use it also as a way to filter. I mean, I could have said, well, add some where clauses to my Cypher expression that would filter out certain elements, or maybe promote certain others and give the priority. I don't know if that sort of answers the question, but feel free to comment if that didn't. But the search itself on the vector index is entirely, vector similarity, and then it's up to you to kind of filter out and remove or add with the Cypher part.
Okay, cool. And the other question was here from Lila. Is there a way to control how many entities are matched?
I believe that's. I'm interpreting it as in the retrieval step for vector, but I'm not sure that's where the question goes. In this case, you're indicating the top n, top 3, so you can specify how many are returned. So where do you set the cut? I hope that was the question. If not, please.
I think so too. But yeah, like you said, I mean, a couple of questions came in, and I wanted to get you completed before interrupting some more. Hutch is explaining some more. I was wondering if the vector search found the node first and then used the relationships from the node to give context to the properties of relationship nodes to improve the result. So I guess
the node to give, I mean, context of the property. Yes, I actually, that's a good point that you bring it up, because I went a bit quickly over that. But when we did the RAG vector and graph, I skipped over a particular element. So I said that you specify a query, and the query returns certain properties. Right? In my case, it returns the item sold, which is actually one of the property values, and the items return, which is again an aggregate from them, and then the text field in the node. So there's this thing called the result format. First of all, you can return, to your point, Hutch, you can choose all the properties. You can even return a path. You can return all the context that you want. It's entirely up to you. But there's this object that helps you kind of putting it in the right shape. And it's a result formatter. And basically for every record that's returned by this query, you put it in a nice format. So, and what I'm doing here is I'm saying, well, the product description is the content of the text field. And then the sales count is this, and the returns count is this. And I'm kind of formatting the results in a nice way, and even providing some metadata. But here you could take the opportunity to, take certain properties from the node itself, from the relationships, from neighboring nodes. So you can really pick whatever you think is going to be relevant, or even pass the whole set of properties of a given node, if that's what you need. So you can basically take control over what information is passed to the LLM, or pass back for the generation part.
Cool. Then I have one more question from David here. David points out that LangChain has a Neo4j module which includes a graph Q&A class, which looks like has been created specifically for graph RAG, and it seems supported by Neo4j. Are there any benefits, restrictions in using the LangChain module, or do you have any?
No. That's entirely your preference, and I understand that some people are familiar with LangChain and prefer to use that approach. So these two, I mean, historically, the LangChain integration was driven by our DevRel team, and one of the most active people there has been Thomas Bratenich. Now this is being kind of all better organized and managed by product, and that means that it's part of our offering, that it's supported, that it's maintained on a more regular basis. Later, thank you. But yes, no, it's just, I mean, you can achieve pretty much the same things, at least in the retrieval part, and ideally the source code, and that's my understanding, is that the team will reuse and have these two work consistently, and probably behave in a similar way. But at the moment, they're just two ways of achieving the same thing. If you're more familiar with the LangChain APIs, that's perfect. If you want to use the GraphRag package, that's perfect as well. So
cool, sounds good. And then I have one more from Blagoya, and they ask, how do you compare the performance of those RAG approaches you just demonstrated?
That's very good question, and it's true that up till here we take a very empiric approach. So you basically take a bunch of examples and then you put them side by side, and it's inevitable that there's an element of there's frameworks like Ragas and things like that. So but ultimately it's going to come down to creating a collection of, I make the analogy with unit tests, right? So you have a question and you have an expected answer. Is the answer that the LLM is producing, assuming that's natural language and that it's a paragraph of English, is rich enough? I mean, does it not include too much noise? So there's metrics in frameworks like Ragas to do that. But yes, ultimately it's a bit laborious in the sense that you have to provide a set of examples, a set of tests to quantify that. And of course, doing it at scale becomes that's a problem a situation that we find quite often, right? When our customers say, yes, I see the value, I want to invest in that, but is there a way to quantify the benefit and the to justify the costs? And that's a common thing. So, but it's based on these type of frameworks. So that's what I would recommend you have a look
at. I have more questions here, but I don't know. Did you had any?
Well,
maybe have 5 more minutes. So
probably better to answer the live ones, because if they're yes, we have some, but I think probably these are more relevant and more close to today's session. So if you have some, let's look at them.
The others I have are more generic. I could read them out, but we could also cover something else. There's one on from because you mentioned it, I guess maybe interesting. Manvendra asks, can you tell us something about APOC? It was part of one of your queries, and
sure.
What it is.
Well, APOC is a collection of procedures and functions that extend the functionality in Cypher, and it's built into Aura, for example. So at least the APOC core, and it's useful for it offers a bunch of utility functions for things like what you just saw there, right? To do model refactoring, I could write 10 lines of Cypher to do what I did there, like take two nodes and combine them into one, make all the relationships come in, come out, or just have a call at this function that will do it for me. So ultimately, I like, in a way, like stored procedures that simplify a number of tasks. And I would recommend you go, and I'm sure you've done it already, Alex, put the documentation there.
I put the link to docs. Indeed.
And so it's super useful, and I think everyone who's built something on Neo4j has used that in some capacity. So yeah.
It's just important that you differentiate the two editions, core and extended, so that you don't expect some things to work on. If you don't have extended in, they won't work on core.
Mm-hmm. That's right. Yeah.
Good. And then maybe one more question comes, and that's very generic, and I don't know if we can probably spend a full episode on this. So I think maybe we will not have time to fully answer this question, David, but just in case. David says, if a client has a stack of data that is already stored in a relational database, and they have apps on top of this database and all of that, how would one determine, from a client's perspective, from actually a database administrator or architect's perspective, is how would you determine that you gain value from migrating to a graph database versus cost, for example, return of investment, or should the client redevelop their work on top of a graph database and have then two sets with the same data, one relational, one in the graph format?
That's a very good question, and it doesn't. I mean, I cannot give you a categorical answer, as you can imagine. I mean, I would say in the general case, if you make the effort to put it already in a structured fashion in a data warehouse, I wouldn't say that it makes any sense to systematically go and dump it into a graph. I mean, it will be your choice as an architect or as the expert in the domain to figure out. I mean, does it make sense to take an approach where the graph maybe just captures and we have examples of that. Maybe that's something that we could try in one of the episodes. But we have examples where the graph captures actually the metadata. Let's say you have multiple sources of data. You have data warehouses, but you have also operational, systems. You may have document databases, whatever. So the graph actually contains what's sometimes called a semantic layer, which is a description of the entity, basically the ontology, and some mapping to the underlying sources. So an indication of, hey, customer data can come from this table in your data warehouse or from this document collection in your document database. And basically what you do in the retrieval step is go to the knowledge graph, express your question in terms of the ontology, and figure out which is the underlying set of sources that you need to use. And then based on that, generate, if it's a SQL, because it's relational, a SQL query, if it's another type of query, but basically generate the query in terms of the underlying system. So these would work in a more sort of virtualized approach where you just capture in the graph the metadata, but the data stays where it lives. But that said, it's perfectly justified in cases where there's highly connected data to take the slice of this data living in your data warehouse or in your data lake and dump it into the graph for efficiency. There's a number of things that we've touched on over the years, over the months, which is not just the performance and the detection of patterns, which becomes tricky and relational, but things like more advanced, like algorithms. You might want to do clustering. You might want to do centrality. So sometimes representing data as a graph opens the door for some additional analytics. So yeah, it's a consulting sort of answer. It depends, but
Yeah.
I wouldn't say that systematically it's something we would recommend. Like take all your data and put in a graph. Identify the portions of the data that are relevant to some graph processing, graph analysis, and that's the bit that you would need to bring into the graph. So, short and quick answer, but I hope that gives you some pointers and some ideas.
Yeah, perfect. Cool. I'm sorry if we couldn't answer your question. I see there were a couple of others still, but I think in the interest of time, I think we will have to wrap our episode for today. As I said in the beginning, if you have more questions, find answers in the Discord server, on the community forums, or put your questions in the YouTube comment section under this video, and then we can look at those later on and get some answers to you. What's happening next is this stream on the 6th of February, so in 2 days' time. I'm talking to Daniel about Bundesflow, which is an AI for legislative transparency. So he's analyzing law texts that have been passed into law, and because it's German election in February as well, the party's program for their what they want to do in the next term. So I think that's going to be an interesting presentation in 2 days' time. And next week, Paul from the Neo4j team joins me for the Neo4j Rust driver to give a bit of a background on how that works and what it does and what its capabilities are. So if you are developing on Rust or want to develop Neo4j and Rust alongside each other, then maybe this is interesting to you. And yeah, what else to say? Developer service still running. So if that is something you're interested in giving us feedback, then let us know there. And yeah, as usual, the important links. Graph Academy to learn to discover more. Obviously, there is a GraphRag workshop as well. So if you find this interesting and are just about to start, go to Graph Academy, take the course. It gives you like a great starting point. It gives you all the information you need to get started. Aura free. Jesus showed it as well in our presentation today. It's a great tool to get started without any need to download or install or maintain anything. It's very, very low friction. And like I said, more information on our developer page, as always. Yeah, and with that, I think if you watch this on YouTube and you like this, or if you watch it later on, please give it a thumbs up. Subscribe to the channel. Let us know if you like it. Let us know what you want from future episodes. If you have any feedback, any other comments or wishes for future episodes, we're always open for suggestions. So let us know what you prefer, what you like, and yeah, I think with that, thank you for watching. Thank you for taking part. Thank you for all your questions. And obviously, Jesus, thank you very much for the great demo again, for giving a bit more background on it's like a plus episode from last month. And yeah, for taking the time again.
I was thinking that we should probably reconsider the title, because in the end it was like more on that Q&A. But no, it was great. Thank you very much, Alex, and looking forward to the next one.
Yeah, perfect. Thank you all for watching. Stay tuned for more from the Neo4j channel. And with that, have a good rest of your day, rest of the week. Hope to see you on Thursday for the next Neo4j Live or somewhere else around. If you are at JFocus, say hi. All right. With that, bye-bye, everybody.